Okay, so welcome to this week's weekly workshop. We are continuing our discussion of various types of CTF challenges, and today we're going to finish up our discussion of networking challenges. So this has hopefully been helpful. We've delved into various different kinds of CTF challenge, different kinds of networking CTF challenges, and hopefully we've learned a fair amount about what we can do with Wireshark. There's certainly way more to do with Wireshark than we've discussed so far, but powerful tool does lots of great things. And today I'm going to finish up and talk about file carving. So this is a little bit more advanced than most of what we've been involved with is sort of looking at headers, at various different kinds of packets, and digging into some of the application layer data in network interactions between client and server, for web pages or FTP servers or that kind of stuff. Here we're actually going to carve a file out of an interaction between a client and a server. In this case, it's going to be a connection to a web server, but the process is very similar. And so I'll talk more about that when we get to it. So we'll do sort of the hard way, the old school way to carve a file, and then I'll show you a way that it can be done sort of quicker and easier. But the quicker and easier way doesn't always work. I'll sort of give you that warning. So knowing how to do it the old-fashioned way is absolutely essential to solve some of these more difficult networking CTF challenges. Before that, let's cover some of the housekeeping. First, you can play along with this, right? So hopefully folks have been playing along and been solving all kinds of cool CTF challenges. There's a practice CTF, so if you go to https:/practice CTF, of course my pen isn't working again, never works the first time. This will get you to the CTF challenges that we're talking about during these weekly workshops, and there's also more challenges that we haven't talked about that'll give you some a little bit of hands-on practice time. Good way to approach this is to point your students to that CTF. It's open and available to anybody who wants to access it. Point your students to it, let them hack on some of the CTF challenges, and then take a look at some of these workshops that sort of provide solutions. Or you can watch the solutions yourself, and then point the students at CTF challenges, and then if they solve it, great. If they don't, then you'll know how to approach it. Lots of different ways to use these workshop videos. So if you need a Linux environment, then here's the instructions for you to get access to a Kali Linux machine in the Cyber Basics 2018 environment. So if you don't have one readily available, here's how to get one, and I would advise you to just do a quick screenshot of this slide so that you can do it, because I'm going to switch slides. Weekly workshops every week, Tuesdays at 1 p.m. recorded, of course, put up on the Virginia Cyber Range website. So that's probably where most folks got a hold of this one. And if you'd like to see more, then, or if you'd like to see a particular topic, then please send it to me or to contact@Virginia Cyber Range, and we will add that to our list. A couple of quick news stories. I won't dwell on the news, but if you're not interested in the news, then fast forward 10 minutes or so, and we'll dive into the file carving stuff. So there's an annual event called Pwn to Own. PWN is an old hacker term. And the origins are murky, but basically it means to hack something. It means to own it is to gain admin privileges on a device, and so this term pwn has became a thing many years ago, and as a sort of synonym for own. So here they mean pwn as in own the device or the system, and then the own part of it is if you hack the device, then you get to keep it. Is historically the way this pwn to own competition has gone. So this is something that's happened since it's over 10 years old. It's I think the first one was in 2007, and this is happens as part of the CanSec West security conference. So Canadian Security, Canada Security West is, CanSec West. It's held as somewhere in the western part of Canada every year. And this year, a lot of times, it started out with like mobile devices and things like that. So like a smartphone, if you're able to hack into the smartphone, then you get to keep the smartphone, for example. And again, this has been going on for many years, and every year they get different kinds of devices, different kinds of software for these folks to try to hack into, and most of them show up at this thing with a with the solution, right? They know how they've for the most part solved the problem. They've figured out how to hack it, and then what they're doing at the Pwn to Own usually is just demonstrating that they have a hack that'll work. So here's some winners from this year. At the very top here, so the big Pwn to Own prize this year was a Tesla Model 3, and so basically if a group could hack the Tesla Model 3, then they got to keep it. And this group, fluoroacetate, the names are there, Amat, and Richard Zhu, they were able to hack the car, gain root access to the software in the car, and so they got to keep the car, and they got $35,000 on top of that. The way they were able to hack it was there was basically a web application flaw in the there's a touch panel that is basically runs kind of like a website. It's the touch panel in the between the driver's seat and the passenger seat on the dashboard, and it had this Java token vulnerability that they were able to exploit and gain root access to the device. Microsoft Edge, so you'll see the same group on all these. Fluoroacetate, they basically certainly won this whole competition by hacking all these different devices, but other people were able to get different levels of access. And so you see that there's different dollar values as prizes. So like the Microsoft Edge, for example, if a vulnerability gives root access, it's worth a certain number of points. If it only gets user level access, it's worth a different number of points. So there are different levels for prize awards, but and the prizes, I think the prize awards, I think the money is actually provided by the company that of the software that's getting hacked. So I believe it's sort of like a bug bounty kind of a thing. They definitely have to demonstrate their hack during the competition. Anyway, so Microsoft Edge, the bunch of prize money for hacking the latest version of Microsoft Edge, Safari, Firefox, same stuff. Anyway, you'll see this every year, this competition, Pwn to Own, that happens up in Canada. Nothing's ever safe, right? All these things got hacked by multiple people. Some other quick news. ASUS, so this has been news over the last couple of days. Hackers were able to penetrate the ASUS software update system, right? So like think of Microsoft Update, where on a regular basis, weekly or maybe every couple of weeks, your computer gets automatically updated by Microsoft, and its settings on your in your Windows 10 basically says call out to Microsoft and see if there's an update, and if there's an update, then it's your auto update thing is going to pull the update and it's going to install it. Well, ASUS does something similar for their ASUS makes hardware, laptop computers, and etc. So they have a software update system, and if you own an ASUS computer, I'm sure I have an ASUS laptop laying around my house. Every once in a while, that thing may call out to ASUS and see if it needs an update, and if it does, it's going to tell you to click the button to update. And turns out that hackers were able to penetrate their update system, so they were able to install malware into the updates, and so when people automatically updated their ASUS hardware, they got hacked. So that's what we consider to be a supply chain hack, right? So that's something that, it's not a user clicking on a malicious link. It's not, the user is sort of out of the picture. other than the fact that they allow their system to be auto-updated, or they allow their system to be updated at all, which is a thing that we certainly encourage people to do, right? Update your software, because it'll help fix vulnerabilities. In this case, the software update created a pretty significant vulnerability. So that's kind of a scary attack. But that sort of should inform the importance of the companies like ASUS and others to make sure that they secure their back end that could cause this kind of thing to happen. And then another story here, another failure by a company. Facebook stored millions of passwords in plain text, so these are text. So that's the Wired.com headline. Actually, it's hundreds of millions of passwords dating back to 2012. This was first reported last week by Brian Krebs on security.com. The news here is that, of course, there's no best practice anywhere that says an organization should store passwords in plain text. They should always be hashed. There's some argument for encryption instead of hashing. Of course, with encryption, you can turn the encrypted thing back into the plain text password if you have the encryption key, but surely encryption is better than storing in plain text. Anyway, Facebook has got this internal investigation ongoing because they discovered hundreds of millions of passwords that were stored over various systems in plain text, and this is news that's it's still unfolding, right? But right now, the best guess is that these were these are the artifacts of troubleshooting software issues. So some developer, there's something that's not quite right in some software, and a developer wants to troubleshoot it, so he throws in some hack where okay, well, in order to test as the user, we got to be able to log in as the user, so I'm going to throw in this hack where I get his username and password in plain text, and then they fix the problem, but they don't fix the thing that is saving that username password combination. And the result is that hundreds of millions of passwords dating back to 2012 are stored at Facebook in plain text, and Facebook's trying to clean up the mess right now. But what Wired magazine says is, if you have a Facebook account, then you should change the password, because somebody at Facebook, lots of people at Facebook would have access to it. There's no indication right now that those plain text passwords were accessed by any external entity, right? There's no compromise alleged, but people inside Facebook would have access to the plain text passwords. Okay, today we're going to talk about more networking, CTF challenges, and then next week we will delve into something else. I think web. I think we'll be doing web challenges next. All right, snapshot this if you want to play along, if you didn't do it before. And now I'm going to, so you notice I already have my Kali Linux Virginia Cyber Range machine up and running in the background here. So I'm going to pull up backer.io/practice-CTF. I'm going to log in. I let Chrome keep my password for this. I don't generally do that, but this Cyber Range machine I think is okay. For the risk is low, right? Okay, so we've done a bunch of these networking challenges already, and if you haven't done these, then take a look at the last the series of CTF weekly workshops before this. Done a bunch of the networking ones. I spent a couple of weeks on crypto, 2 or 3 weeks on crypto. I've talked a lot about networking, and that to me makes perfect sense. Networking is sort of the bread and butter of cybersecurity, right? So being able to do a lot of CTF challenges, you have to do some networking thing first before you can even get to the crypto challenge. For example, you might have to carve a file out of an email exchange that is a encrypted file, and you have to figure out how to decrypt it using some crypto techniques, for example. So networking is a little bit, bread and butter, and so the more the more skill you can develop attacking different networking challenges, then the better off you're going to be, I think. So we will look at a couple of challenges today. Mostly we're going to focus on this one called file extraction. So first thing I want to do is I want to pull up my slides again. So these are my slides. I need to make these available somewhere so you can go back and refer to them. Although I will say that I update these as I continue through these discussion of challenges. So they're different than they were when I first started. So we've talked a lot about networking challenges over the last few weeks. We talked about Wireshark and display filters so that you can filter out particular kinds of traffic in your packet capture. We have talked about Boolean expressions, so you can get very refined in your Wireshark filters. We took a look at we took a look at an HTTP exchange, right? So it's a basic Wireshark. So in the cyber range, we turned on Wireshark. We went and grabbed a web page, and then we opened up the PCAP and looked at the three-way handshake. We looked at the HTTP file getting transferred to the client, and et cetera. So it's I think helpful to be able to see some of this live network traffic to get a better sense of what network traffic looks like. The theory behind it says, well, there's this TCP three-way handshake, and it's a packet here, packet there, packet here. You should be able to see it. Then there's a request for a web page, and you get the response, and that's all true. But but in and amongst those exchanges, there's a whole bunch of other stuff that's going on the network, and until you really see it in real time live on Wireshark or some other tool, you just don't get a sense of how much stuff is on the network. And so so this is a good exercise, I think, to go through. I did this, I think, on the first web CTF, or I'm sorry, the first CTF networking challenge workshop I did 3 or 4 weeks ago. Then we went on to look at some challenges that used HTTP, FTP, SMTP, and others. And so now we're going to talk about file carving. And so again, here is in file carving, what we have to do in this particular challenge, and in a couple of challenges I'm going to point to today, we have to grab a file that is in an exchange between a client and a server in a PCAP file. So we have a PCAP, and the first file carving exercise we're going to do is an HTTP transaction, right? So somebody opens their web browser and browses to a file that's on a web server, and the file is served to that person over the network. And so, of course, you can imagine a file is a file has to be transferred from one endpoint to another endpoint, but that file is contained in network traffic, and so you have to be able to identify the beginning and the end of the file so that you can carve that file out of the rest of the network traffic. So that's what file carving refers to. You're taking a larger blob of bits that is being transferred between two endpoints, and you're carving out the thing that you care about, which in this case is a JPEG, a picture file. So in CTFs and in incident response, right? So this is not just a CTF thing. When you're, the reason you want to learn how to do this is because as a cybersecurity expert, or as a Intel analyst, or as an incident responder or as a forensics investigator, there's often the requirement to be able to extract individual files out of packet captures. So in CTFs and in incident response and digital forensics and otherwise, you'll sometimes need to carve files from network traffic. The file type, so knowing what the file type is not always completely obvious. The file type may be identified in the network traffic header, and so I'll show you where to find that. In this particular case, I'll show you how to find what the file type is. But I'll tell you, going in, you won't always know what the file type is, and so sometimes part of the challenge is to identify the file type, and we'll talk about this notion of magic numbers as a way to do that. Third bullet here, various file types have different signatures, which makes it easier to identify the beginning and the end of the file, right? You can, we're going to take a look at an exchange between a client and a server, and in order to extract the file, we're going to have to look at that interaction in raw format, and raw format is just, it's bits on the wire, bits, zeros and ones, but we're going to look at it in hexadecimal representation. So instead of just looking at the bits, we take 16 bits at a time. We turn them into a hexadecimal value, and so we're going to look at hex representations of the raw data. And when you're looking at that, you're seeing 0 through 9 and A through F, and it looks certainly not very intelligible. But in order to carve the file out of that glob of data, you have to be able to identify the beginning and the end of the file, and you do that using what are often referred to as magic numbers. You'll also hear the term file signatures. So various types of files have different signatures, which makes it easier to identify the beginning and the end, often referred to as magic numbers. And so I provide a web page here, wikipedia.org/wiki/list of file signatures. If I click on that, we get a web browser tab that opens up. So this particular page is a great resource. It's in Wikipedia, so it's updated over time, edited as this information it changes. But you look at all these different kinds of files. So a PCAP file, an RPM, that's a package management file for so Red Hat Package Manager, RPM packages, database files, binary files, things you probably never even heard of, GIFs, so the graphic interchange format, TIFF, tagged image file format, so these are different kinds of image files, BPG, what is it? Better portable graphics format. So JPEG. This is the one we're going to look at today. So in order to find the file in the traffic, being able to identify. So for example, for a JPEG, we need to find this sequence of characters: FFD8, FFDB, or FFD8, FFE0. That'll help us identify the beginning of the JPEG file. And then there's another footer hexadecimal value. So here at the bottom of the slide, I give some example file signatures. So for example, if you are looking for a document file, then you're going to look for this D0CF11E0 A1B11A E1. And so this, if you have a bunch of network traffic and you see this in there, then that tells you, okay, this is the beginning of a Word document file, and then in order to find the end of that file, you're going to be looking for something like this. If you know what kind of file you're looking for, then that certainly helps, right? So for example, here's our JPEG file header and footer. So I can look for FFD8, FFE0, whoops, and that makes it, I search for that, and then if I find that, it's a pretty good indicator that I'm dealing with a JPEG. JPEG is a graphics, image graphics format. And then when I need to find the end of the file, then I just search for the FFD9, and that tells me that's the end of my file. And then we'll see in a second that the ASCII representation of these characters are JFIF, so that makes a JPEG file even easier to find, because if you open the file in a hex editor that shows the hex and then the ASCII representation on the other side, then you'll often see this JFIF, and that says, okay, I'm working with an image file. So then you back off 6 bytes, and that brings you'll see the FFD8, FFE0. Okay, so we're going to do this now. We're going to do a hands-on file carving exercise. The challenge is called file extraction. So the first step in our file carving exercise, first we have to extract the appropriate content from the PCAP file. So we're going to open the challenge. We're going to click on the file download. So it's called filepackets.pcap. Then we're going to open that in Wireshark, right? Step 1, very easy. Download the file, open it in Wireshark. Then we're going to find the HTTP traffic, and the traffic is between the client 128.173.243.7 and a server at 45.55.180.222. So we're going to find that HTTP interaction. All we have to do is find one of the packets going to or from between those two endpoints. And then we right-click the packet and right-click any of those packets and select Follow TCP Stream. So up to here, we've done this all before, right? So we're going to get the TCP stream. So let's do that. So again, I open up my vacker.io/practicectf, and I'm going to click on this thing called file extraction, and I'm going to click on the PCAP, and I'm going to save it. And then I'm going to go to, so I'll open up Wireshark. Here. This is not how I usually open Wireshark. Should be easier than this, huh? Internet, there we go. Wireshark. Easy way is to open up a terminal window and type in Wireshark. Okay, here we are. And I'm going to open up filepackets.pcap. There it is. Okay, so I'm looking for exchanges between, sorry about that, between these two IP addresses, 128.173.243.7 and 45.55.180.222, and it's HTTP traffic. So might make it easier for me if I go to my filter here and say HTTP. Oh, that drilled way down. Okay, so now I'm going to say follow TCP stream. Okay, so here we go. I have a client. I have a client at 128.173.243.7. I have a server at 45.55.180.222. And so here's my, it's in SYNAC, so it's through a handshake in order to set up the connection between the web browser and the web server. And then I do a GET request. I'm getting /stuff/file. Here's the acknowledgement and the packet. Oh, that's the acknowledgement. Here's the HTTP 1.1 200 OK. That's the server saying, yes, I have that file, and I'm going to go ahead and send it to you. And then the server sends the file to the client, and then there's another interaction that we don't care so much about. So we followed that TCP stream, and here's what we have. We have the GET request. We have the response from the server, HTTP 1.1 200 OK. Yes, I have the file, and I'm going to send it to you. Then we have something being sent. looks like a bunch of gobbledygook, and then here's the client again. So when you follow a TCP stream, you get the client in red and the server in blue. So the client request is here, the server response, and then we go down to the bottom here and we get another client request and server response. Okay, so out of all this, we need to pull our traffic. So we've got our TCP stream, and we're going to look at it in raw format, and we only care about the traffic. Now, we could pull all that data down and still do the same thing that I'm getting ready to do, but we know that the file is transferred from the server to the client, so we really don't care about the data that's transferred from the client to the server. And this follow TCP stream window lets you select either the entire conversation or the traffic from the server to the client or the traffic from the client to the server. And in this case, we're going to only select the traffic from the server to the client. How do we know it's from the server? Well, it's coming from TCP port 80, and that's the web server port. So I click there, and now the client, the red traffic is gone. I only have the blue, the server traffic. And then I'm going to click. Now I could save this as ASCII, but this wouldn't work. I mean, I can't carve what I need to carve out of ASCII text. I need to save it as raw text or as raw data. Raw data. Okay, here's my raw data, and it's pretty raw, right? It's a bunch of hexadecimal values. So at least I'm not getting shown this in binary, because that would be a big series of ones and zeros, but it's hexadecimal data. So now I'm going to save as, and I will just dump it in my student folder, home/student, and I'm going to save it as file. We'll say I'm not quite sure what it is. I mean, I do know what it is, right? So how do I know what it is? Well, let's go back to our ASCII representation, and if I look at the entire conversation, we see that we see somewhere that it's a JPEG. Yeah, so here we go. This is Wireshark. It's sending the data, and it says right in the head, right in the info field that it's JPEG, JFIF image. So it's JPEG image. So we know it's a JPEG. Okay, so so now I can close Wireshark. I've done what I need to do with Wireshark. And if I open my file browser, there's this thing in there now called file, right? But if I open up terminal, what I'd like to be able to do is say file and then file. And what should that do? That should tell me what kind of a file is it. Well, it just says data. Why does it say data? Why does it not tell me that it's a JPEG? Well, it doesn't tell me it's a JPEG because you know, when I double click on it in this file manager window, it also doesn't give me any indication of what kind of file it is. You know, why is that? Well, because it's got the JPEG header in it, but the JPEG header is not where it's supposed to be. The JPEG header is supposed to be right at the beginning of the file, and the footer is supposed to be right at the end of the file. And if those things aren't in the right place, then your operating system isn't going to be able to identify them properly. So now we've got the entire JPEG image in this file, but we need to get rid of the fluff. And so that's the next step in our process. Okay, so we've followed the TCP stream. We've set the direction selector down at the bottom of the TCP stream window and selected traffic from the server to the client. And then we've selected show and save data as. We've changed that to raw. So we get the raw data. That's what we need to save. If we save it in a different format, then we're not going to be able to carve it properly. And I've saved it in the home/student folder with the name file. Okay, now the next step is to open it up in a hex editor. So we're going to remove the extraneous data from the front and the end of the file. We're going to use the bless hex editor to do that. And bless doesn't come with Kali Linux. There's probably something else. I guess I didn't look at this. Bless is the Linux-based hex editor that I have most that I'm most comfortable with. So I just installed it. So in order to do it, I did sudo apt-get update and then sudo apt-get -y install bless. I'm not going to do that now. I've already done that. I'm not going to do it now because it takes a few minutes, and I'll just be standing here looking at my screen. But if you're going to use bless for this, you have to install it on the Kali Linux VM. So once we install that hex editor, then we can open the file in bless, and then we're going to remove we're going to find the magic number for the JPEG header. Again, in this case we know it's a JPEG file, and it looks like this: FFD8, FFE0, and then we're going to delete everything before that. So here's a picture here on the upper right hand side. So I found that value, FFD8. Well, okay, where is it? Oh, I didn't find the right value. Where is it? Oh, here it is, FFD8, FFE0. I guess I'm going to replace my picture. FFD8, FFE0. And so I'm going to find that, and I'm going to delete everything before that. And then I'm going to go towards the end of the file, and I'm going to find the trailer magic number, FFD9, and delete everything after that. And then I'm going to save the file from bless. So in this case, I'll give it a JPEG file extension. And then I'll open it using the image editor. Basically, I'll just double click on it in the file manager window. Okay, so I'm going to go through that whole process, and I'll talk my way through as I'm doing it. Okay, so I've installed bless. So I'm going to say bless. Oops, spell. I don't have to spell. I just need a tab. Okay, so I'm going to open this thing in bless. So here's my file. And if I look at the right side here, I see the header, right? Here's the HTTP header data, and then in the middle is a bunch of gobbledygook, and then down at the bottom is another HTTP, you can recognize this as an HTTP exchange. So we've got to get rid of all that stuff in the middle. So let's first search for, so you want this, we're gonna search for FFD8, and we want to search in hexadecimal. So I think when you open bless the first time, I think that's by default, I think it's set to text. So you need to change this to hexadecimal. And then when I do that search, here it is, FFD8, FFE0. And it's 6 bytes before this JFIF. So this is kind of a dead giveaway for a JPEG file. In fact, if you have a packet capture and you think you're supposed to carve a file out of it, then doing a ngrep and looking for the uppercase JFIF will tell you whether or not there are JPEG images in the exchange. You could probably also run strings against it, and if you find JFIF again, you know that so I could do that over here, right? I could say strings. Could I run it against the packet capture? Downloads, file packets, packets.pcap. Maybe I do that, and then I grep JFIF. Yeah, so it's in there, right? There it is. So that's my strings output. So anyway, that's a way that you could identify whether there are images in your packet capture file. So here's my FFD8, FFE0. I'm going to select everything before that, delete. Okay, now I get the right stuff at the beginning of my file. I have 6 bytes and then JFIF. Now I go to the bottom, and I need to find, well, let's just do this. FF FFD9. Okay, here I am at the bottom, FFD9. So now I can select everything after this. I can delete. Now my file ends the way it's supposed to end. So now I can say file, save as, file.jpg. I'm going to put it in the student directory, file.jpg, and save. So now if I do an ls, what happened? Something didn't happen right. Did not save. I'm going to ignore. File, save as. File.jpg. It's not working. Save as. Okay, just showing it. Yeah, file.jpg. Okay. So I ended up saving it in home student downloads file.jpg. I'm not sure why it wouldn't save in home student. It's a puzzler, but anyway. Downloads. Okay, now I have this thing called file.jpg, right? So I carved. I found the FFD8 and I deleted everything before that. I found the FFD9, deleted everything after that. Now I could say, now I could ask the file command, file.jpg, what it is, and I get the, well, let me close blast because I'm getting all these crazy errors at the command line are bless. CD downloads. And here I get, it's a JPEG image file, JFIF standard, yada, yada, yada. So now I see it in my File Explorer. I double click on the file.jpg, and here's my flag, right? Here's your flag. And this is not a text file, it's an image file, so I can't just do the selection. But what I can do is I can go to my thing here and I can say H3R3S underscore Y0UR underscore FLAG. And there we go, solved that challenge. So, so that challenge is solved. There's another challenge called, I'm gonna add another challenge called anonymous in here that you can use that same technique. I'll say that it's that in the anonymous challenge is a little bit more involved, right? So this challenge was very straightforward. The web exchange was one single request for a web page and response, and that JPEG file was the only thing in the response, right? So this was sort of best case scenario in terms of the ease of carving the file. It's much more difficult if the files you're looking for are in and amongst a whole bunch of other content. You know, you may have a whole bunch of image files. You're not quite sure which one you're looking for. You know, you may have it in an email or in an FTP exchange or in some other sort of exchange. So you'll see different applications of this, but the basic approach is very similar. Now, I mentioned that there's an easier way, and so let me go back to my slides. So we've done this whole thing, right? We've done the manual file carving. Good to know how to do this. That's some fairly advanced Wireshark stuff. So we're going to do the same challenge again, but we're going to use Wireshark. So Wireshark provides an automated file carving tool, and this is a I'm not sure when this feature was added to Wireshark. Maybe not super recently. I'm just not sure. I've used Wireshark for a long time, and the original versions didn't do this kind of thing. But you can imagine that if we know these different file types and the different magic numbers used to identify them, then you could add a plugin to Wireshark that would automatically do some file carving. And so that now exists in Wireshark, and I'm going to show you how to use it. I will say that this doesn't always work, so don't count on this working. So if you do, if you take this approach that I'm going to show you to try to carve images or other files out of PCAP and you don't get any results, that doesn't mean that there aren't any files in the PCAP. That just means that this tool didn't work. So it's not completely reliable, and I know that for certain because I've tried it on PCAPs that I know that there are files in, and it just isn't able to carve everything. So so in order to make this work, the first thing you have to do is configure Wireshark to allow TCP stream reassembly. And I believe this is the default in Wireshark, so you may not have to do this. But if you try to do the second step and it doesn't work, then maybe your Wireshark is not configured properly. So here's how you make sure it's configured right. You go to Edit Preferences, Protocols, TCP, and you enable. There's a checkbox to enable Subdissector to reassemble TCP streams. So Edit Preferences, Protocol, TCP. So I'm going to open up my Wireshark. Well, let me open up the. I'm just going to go straight to opening this guy. File, Preferences, Protocols, File. Oh, I'm sorry, it should be Edit Preferences. Edit Preferences. And then you go to Protocols. And then you go to, wow, look at all these protocols. Recognize this. Go to FTP. Oops, I'm sorry, TCP. Oh, protocols, TCP. And you're going to allow, this checkbox right here, allow Subdissector to reassemble TCP streams. Okay, and the next thing, yeah, I got to fix my slide. Huh? Next thing you do, oh, no, I had it right. Edit Preferences, Protocols, TCP. Okay. Next thing you do is you find the objects in Expert. So now you go back to where you can close the Preferences window, go back to Wireshark, and then you want to make sure that your file is open that you're going to examine. And then you're going to select File, Export Objects, and then there's different file types. It says file types, but really it's looking for protocol exchanges. In this case, we're going to select HTTP, and then you select files to export. So let's go to File, and we're going to export objects. And then we're going to export, we're going to look for HTTP. And what this does is it tries to find files that are embedded in HTTP traffic. In this case, it found on the host name denomyard, DNOMYARD.com. It found a file called file that's 2,187 bytes long. And then it also found this favicon.ico. This is the one that we care about. So we're going to save this. I'm going to say save. I'll save it to, let me save it to this temp. Save it to temp, home student temp, save. Okay, so now if I go to cd into temp, now this thing called file is there. So it's right here. So now I could say file, file, and it carved it, so I know that it's a JPEG image. And so I could open my browser thingy, and I could go to temp and this thing called file. Even without the file extension, I get what I want, right? So there's my flag. Okay, two different approaches to that same CTF challenge. All right. So that takes us to the end of the networking challenges in our exploration of CTF challenges. Next week, we're going to dive into something else, and I'm fairly certain that we're going to start doing we'll start doing web challenges next. So next week's workshop we'll delve into web challenges, and we'll probably do at least 2 weeks looking at different kinds of web challenges. I don't know, maybe we'll do a third week. We'll see how it goes. So thanks for joining us, and I look forward to seeing everyone at the next weekly workshop. Thanks.